All right, good morning, everybody. I'm Ms. Mitchell. I'll be your teacher for this class, just to introduce myself. So basically, you've all joined the Hangout. So I'm just going to walk you through for the first 15 minutes or so how things are going to work, just to give you whatever information you need to make this as smooth of a transition and as smooth of a class as possible. So just to start out, if you guys could all mute yourselves, it would be super greatly appreciated, because what happens is if you're not muted and you make a noise or you shuffle your papers or whatever it is, it takes over from me and it'll mute me while we hear the noise that you're making. So basically, if you want to always be able to hear me, you need to be muted. That way, there are no interruptions. Feel free, like I said, to ask a question at any time. You can unmute yourself to do that, but otherwise we'll hear all the side noises and people will be jumping and just be a little bit difficult for that. Okay, so perfect. So now I'm going to be walking you through a couple of the things that you need to know and need to be able to do for this class. So we'll start off by the Google Classroom. Okay, so you're all in Google Classroom. Hopefully, so you should have received the email yesterday inviting you. So hopefully everyone's in there, otherwise you wouldn't be in the Hangout anyways. So here we go. Just before we get started on this, I'm about to send in the chat, just got a message from Training 1. That message is a side chat. So unfortunately, we're going to be a big, well, unfortunately or fortunately, we're going to be a big group in the Google Hangout. But with Google's technology and infinite wisdom, you can only have a certain amount of people talking in the chat at one time. So the people that arrive last will not be able to speak or type, but can watch. So that will be a side conversation that I'm checking constantly just to make sure that there aren't any questions. So feel free to ask a question in there. So we've got our stream. Google Classroom is going to be our main method of communication. I'm going to post assignments there, the Hangouts there, solutions, handouts, announcements, everything is going to be going through Google Classroom. If you have a phone, there's an app for that, so you can always get the app if you want to see the notifications as they happen. If not, just check your Google Classroom as frequently as possible. So the first thing we are going to do, as per our schedule, course outline. So you are in the secondary for the TS group. So this is a bridge course. So the assumption is that you took the CST grade 10 throughout the year or last year, depending on when you decided to do it. So that is the expectation. So now what I'm going to do is I'm going to go through the course outlines, just the expectations that I have and the expectations for the course. So in terms of what I expect from you, try to be on time for the Hangout. We'll start between 10:30, 10:30, 3:34, just to give people last minute jumping in, getting everything settled. Be prepared for every class, okay? So it's a bridge course, there's a lot of work. I will be giving you handouts to practice, assignments to complete, so try to complete those as frequently as possible. And super important, respect every member of the class. So we're trying something completely different this year with the Hangouts, which means there's a lot of opportunity to just jump in, interrupt each other, because we're not really used to this type of forum. It's a lot easier in the class when you can see someone with their hand raised or see someone talking. So just be aware that we're all in this classroom, we're all in this Hangout, and we're going to have to get used to it. So just be respectful of that. For evaluation, works exactly the same way it works during the year. You have your sit prop mark and you have your final exam mark. Now, because we didn't evaluate like random sit probs throughout the weeks, you have a sit prob exam. That exam is on the last Wednesday, so not this Wednesday, not next Wednesday, the third Wednesday. So that is an exam day. And then your final exam, the C2, that big one, is on the following Tuesday. So you have 2 exams, 30/70, then your marks get transmitted to the ministry as per usual. As usual for grade 10. Feel free to interrupt me at any time if you have any questions, okay? All right. Wednesday's class. Sorry, I skipped one. Work. Homework will be assigned every single class in 3 different ways. So I'm going to go over those with you in a second, just so we're all familiar with the ways that the homework and work will be given to you. So it is in your best interest to try to complete as many of the problems as possible. Some of them I will be checking over and giving you feedback. Others I won't be. I'll just be giving you the problems and the solutions, which means you're responsible for doing as many of those as possible. Now, it is my recommendation that you do all of them if you can. Obviously, you have only a certain amount of time, whatever. You need to do as many of these as possible because practice makes perfect, as cliche as that is. So every class, every day you should be doing homework, especially the ones that I'm assigning for feedback, so that way you can get some feedback on your work before you go into an exam. Makes sense? We're going to be using Google Forms, Google Documents, and Google Slides. Okay? So that's how I'm going to be giving you feedback, so make sure you do those above anything else. Wednesdays. Wednesdays are the tutorial days. So what is going to happen is we have 2 hours together. You're expected to be there. The first hour, 45 minutes or so, I'm going to be doing a recap of anything that we have done that week or in the last few classes. After that, we are continuing with the new material. So you have to be there because that one will not be videoed. You can't go back and watch it later if you miss something. So you are expected to be in class and be in class prepared. Extra help. Feel free to email me at any time. I check my emails all the time. Send me an email, put a post in Google Classroom so maybe your classmates can answer or they can benefit from your question as well. But feel free anytime, as much as possible, I'm available to help you. All right, so like I said, this is grade 10 TS. You've done grade 10 CST. And lucky for you, there is a lot of overlap between the 2 classes. What this means is I'm going to be teaching you over the next 3 weeks the things that you are missing. Not the things that you have seen throughout the year, because the expectation is that you've seen that stuff, you understand it, you know it, you did well enough in CST to get recommended by your teachers to be doing this class. So just to go over this quickly. On this document, which will be in the Google Classroom, should be in there now, but the students in the last class are having some difficulty accessing it, so just make sure that everyone's there, that's posted properly. So these are the topics from CST that you're expected to know that we will not be covering together until we do exam prep, which will not be very long. So everything to do with lines, slope, functional form, general form, the properties. These are things that you need to know. Quadratic function we'll touch upon a little bit together still, but you still have to know what you knew during the year. Piecewise function, periodic function, step function we'll touch a bit as well during this class, but you still have to have the basics down pat. Most of analytic geometry, there's only one little detail, one little piece of analytic geometry that you didn't cover in CST, so we'll look at that together. But for the rest of it, you need to know it. Distance, midpoint, division point, parallel lines, perpendicular lines, all of that stuff you're expected to know. Systems of equations. Methods, so comparison, elimination, substitution, the solutions, word problems, those are all things that you could be expected to handle in this class as well. Triangles, theorems of congruence, similarity, SAS, ASA, SSS, all that kind of stuff. Similar triangles, making the proportions and solving for values. Metric relations is another thing that is also in this class. Trigonometry is, so SOHCAHTOA is. Area, Hero's formula, and the sine law formula are, but for whatever reason, whoever made up these classes in their infinite wisdom decided that you don't need to know sine law. So chances are you will not need to use SignLaw in any of your problems. You still have it as a tool. If for some reason it's easier for you to use SignLaw, then by all means go for it. You know it, it's right, you can use it, but it's not the expectation. So chances are if you're using it, there is another way you don't need to use it. We'll leave that there. Statistics, mean deviation, you need to know. Correlation, so all of the scatter plots and the correlation coefficient and estimating the correlation coefficient, contingency tables, all of that you need to know. Estimating the Mayer line for predictions, you don't need to know anything but the Mayer line. You may have seen the median line in your classes at school. You can have that again as a tool if you want to. The Mayer line, just knowing the Mayer line is more than enough if that's all you've learned. So that's no problem there. So that's the end of what you're expected to know for CST. So if you're having problems in any of those areas or you want some sort of side explanation or extra notes or extra practice, please let me know. We probably won't have time to cover any of those in class on chat together. So it's important that you're reviewing that stuff on your own. But if you need more materials or you need more explanation, please, please, please do not hesitate, because these things will come up on your final exam. There are a lot of different things that we haven't seen yet. So throughout the 3 weeks, we're going to be covering these different topics. So today we'll cover some of it. Then we'll continue throughout the 3 weeks. So some of it, as you see, exponential function. Functions comes up again, which means we'll cover that in a little bit of detail to help us with the new material that we need to know. But we will not be going over this thoroughly. And everybody's favorite topic, probability, does come up a lot in the TS course, and you haven't done that at all in your CST. So we're going to make sure we cover that in detail as well. So far, so good. Feel free to jump in at any point, ask me to slow down, or ask for a clarification at any point through the chat, or just unmute yourself for a second. Okay. This Google Classroom, like I said, is your lifeline to this course. Super, super, super important. So what I have done is I have uploaded a practice assignment. So there are 3 different ways that we're going to be doing assignments for feedback. So practice assignment on slides, practice assignment on docs, and Google Forms. For each of these things, you have this to practice. I'd like to use the next 5 minutes or so just to look it over to practice to make sure that we're all familiar with the different platforms that we can use, because I will just, moving forward from today, assume you know how to do it, and any questions that you have, you should email me directly. For example, here you have a test quiz. The questions aren't real, obviously. We're just looking at this as a practice. So you have 3 different options, 4 different questions, different options. You choose your answer, you submit, and you're able to see your answers, and you'll get the corrected version right away, so you'll know how you're doing for those type of questions. So if you want to take this now, go ahead, test it out. The other thing that we will be using is slides. I'm just going to explain all 3, and then I'll give you 2 or 3 minutes just to test them all out and see if you have any questions before we move forward. So for slides, if you get a Google slide as an assignment, this is what it would look like. It's not going to say practice assignment, it'll say actual assignment. What it will look like is you'll have the question, either in a picture or whatever. And what I would like from you is you have 2 choices. One is easier than the other, but whatever you want to do, up to you, totally your call. You can take a piece of paper and do your work properly on the piece of paper, nice little picture, and upload the picture here, and I can provide you feedback. There's also the equation tool, so you can actually type all of your work out. But bear in mind that if I'm using slides or docs, it's so that I can give you the most feedback possible. So I need to see all your work, all of it, not just part of it, not just your answer, all of your work. So that can get a bit annoying depending on what topic we're doing if you have to use all of the different equation features. So you might want to go with the write it out by hand, take a picture and upload it, but I leave it up to you. Same thing with the docs. So here is the practice assignment. You're going to be getting one of these as a real assignment. So now's the time to see if you can do it. Question 1, you're going to have the question, whatever it may be, and then you're going to have a text box. Same thing here, calculate the area of the triangle, text box. Same thing. So you're filling it in by hand, or not by hand, sorry, using the equation tool and all of that in the text box, or you're taking a picture and uploading the picture in the text box specifically. So we've all used docs before. We know how messy it can get when you just upload a picture and put it in the middle of nowhere. All of a sudden, everything shifts, and everything looks ugly, and pictures shift, and text shifts, and no, not cool. So put your picture in the text box very specifically, okay? That way nothing shifts and your answer's there, and I can provide you feedback. So take a minute or two now. Just take a look over these 3 different ways. I'm gonna check to see if people have uploaded pictures or if they've completed the Google form. So just try those things, and I'll give you a minute or two and then we'll reconvene. So is everyone comfortable with the different forms, the different methods of assignments? So we have the forms, we have the slides, and we have the docs. Just as a side note, okay, when you're actually doing this for your first assignment, so at 12:30 your assignment will be released. You're going to be getting a Google Doc to fill out. When you're done, make sure you turn it in. So you click turn in. That way, I actually see that you've completed it. Otherwise, you're going to get this thing that says it's late and all that stuff, even though you've actually done it. So make sure you click turn in, and then this assignment actually gets submitted. So we'll be using that. If you have any difficulties at all, please, 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 please email me. We want to make sure that we're doing this properly, that you're not having any issues, and that it's not an accessibility thing that you're having difficulties with. Okay. All right. So, any questions? I'm going to assume silence means no questions. Like I said, feel free to jump in anytime. No problem. All right, so here's how this is going to work. So I just posted something. This is going to be posted every day. The day before, because of how things are going today, just as it's our first meeting, first time getting things going, it was just posted now. But for the future, it'll be posted the day before at the very latest. So your notes for tomorrow will be posted this afternoon. So basically here, you open this and you have your PDF. This is all of the notes that we are going to be covering today with all of the examples that we will be using together. The second thing that's there will be the handout. So this is the practice assignment that you can use to do the problems that we did in class. And I will be posting the solutions to this later today. This, download it, print it, because you'll notice in here there are some blank things that obviously shouldn't be blank. On my copy, it's not blank. So what you expect from you is to print them out the night before, the day before, wherever, whenever I post it, if you want to print it out, and then you'll be filling in anything that's missing. So this is to ensure that you actually watch the video and don't just take the notes and don't watch the video. You should be live with us. That's how you'll get the most out of this class. Okay, so these are the notes. Every day you're going to get something like this, a PDF with everything that you need. So always check out for that. Like I said, if you have a phone, get the app and you'll see when it's uploaded. Makes your life a lot easier. Okay, so I'll give you all a minute to download that, take a look at it, and we'll get started. Okay, so you have the notes open or printed or however you want to do it. If you need another minute, let me know. I'm hoping you can all hear me. Okay. Anything that are on my notes that is in blue, you are missing. That means from your copy, it is gone. Meaning that you have to write it in. So anything that is in blue. So as you see here, we've got a whole lot of blue happening. So what I'm going to do is I am going to let you copy it down, the blue part, and then we'll talk about it together. Okay, so take the next minute, write down the blue section, and then we'll go over it. Okay. Need another minute, let me know. So the first thing we are going to do is we're going to review exponents. Now this becomes very important. We are going to do new material today, but we need this review of exponents to be able to do the new material. So this part might be, not might be, hopefully is somewhat familiar to you. You do cover this in secondary 3. You sometimes use it in CST, sometimes not. So hopefully this is all just refreshing our brain, but not brand new. So just a couple of identities here for us to work with. So anything to the power of 0 gives me 1. Anything. Doesn't matter what it is. To the power of 0 gives me 1. Anything to the power of 1 is just that anything. 2 to the power of 1 is 2. 10 to the power of 1 is 10. So that's a little 1 that we don't actually need to write. It's more annoying for us if we decide to use it. Here. Then we have a negative exponent. What this means is the exponent is not happy. It is not proper form for us to have a negative exponent. So it always needs to be taken care of. How do we take care of it? We have this, for example. Negative means that this exponent is not happy. How do we fix that? Well, if it's on the top of the fraction, it goes to the bottom. Similarly, if we have 3 to the negative 4, if the negative exponent is on the bottom, it needs to go to the top. We have the over 1, which gives us 3 to the 4. So moral of the story is that negative exponents are not happy where they are positioned, and either they need to go from the bottom of the fraction to the top of the fraction, or from the top of the fraction to the bottom. One way or the other, they're not happy. All right. Now we have our exponent rules that you saw, like I said, in secondary 3 in great detail, hopefully. So here we have the different rules. So when you have two things that have the same base, emphasis on the same base, because if they don't have the same base, all of this means nothing. So if you have, for instance, 2 to the 3 times 2 to the 6, we have the same base. What do we do with the exponents? Well, we add them. So this gives me 2 to the 3 plus 6, which is 2 to the 9. We have a similar situation when we are dividing things, again, same base, super important. So if we have 2 to the 9 divided by 2 to the 5, for instance, we have the same base. What do we do with the exponents? Well, we subtract them. 2 to the 9 minus 5, which is 2 to the 4. When you have a product within a bracket with this exponent on the outside, this exponent distributes to every term within the bracket, and it gets its own exponent. So if you have 2x within the bracket, and you have, let's say, a 3 out here, this 3 is distributed to the 2, and the 3 gets distributed to the x, giving you 2 to the 3, x to the 3. Here you have the same thing. So in this case, you have a division or a fraction within a bracket with this power on the outside, but the idea is the same. So this exponent distributes to both terms here. So if we have 2 over 5 to the 4, this 4 gets distributed to the 2, and the 4 gets distributed to the 5. You have a power of a power. What this means is you have an exponent inside the bracket, in this case our m, and you're taking it to the power of n. How do we reduce those? Multiply. So if you have 2 to the 3 to the 5, that gives you the 2 to the 3 times 5, which gives you 2 to the 15. So these are the basic rules that we are going to have to deal with. And these rules are going to be really, really helpful for us when we're doing the new material that we have to cover today. So let's just make sure that we all know what we're doing. So let's do a couple of examples. So here we have -5 to the power of -2. So the first thing I'm going to do is I'm going to pretend this negative doesn't exist, and I'm going to deal with the 2. So here we have -5 to the power of 2, which is actually 25. But I still have that -1 going. As we know, the negative exponent means the number is not happy where it is. So right now it's on the top of the fraction. So put it on the bottom. There's nothing left on the bottom. The top, sorry, so we just put a little 1 in there. When you are doing a division, yes, you're doing top minus bottom. So in theory, this would end up being 3 minus 5, which gives you 2 to the -2. But since this is a negative exponent, it's not happy. So this needs to go 1 over 2 squared. The easier way to do it, or I guess the cheat way, but you can use it, it's fine, is you will do, when you're dividing, do the bigger number minus the smaller. So 5 minus 3 gives you 2. 5 is on the bottom, so the 2 is on the bottom. You basically are doing all of this, but you're doing it in 1 step instead of 2 or 3. Whatever. Whichever way you're more comfortable with, I'm okay with that. Questions? Okay. We're going to take a look at number 5. We'll skip right over number 4 because number 4 is extremely similar to number 2. So number 5, I have a couple of different things happening here. The power of a power. We have multiplication. So as we know, according to BEDMAS or BEMDAS, depending on what your teacher has told you, we have to take care of the brackets first and then the exponents. So there's nothing to do here, so I have to take care of these exponents. They distribute to every term within the bracket. Same thing here. From there, this can be simplified. So you can leave these as they are. A to the 3 and a to the 2, if we remember, gives me 3 plus 2. So I have a to the 5. I'm going to give you a minute. I'd like you to try number 6, and then we'll take a look at it together. So just be warned, number 6 has a lot of different elements. And just a quick trick, do not forget about how to deal with divisions. So take a minute or two, take a quick look, and then we'll look at it together. All right, so let's take a quick look. So again, the first thing we have to deal with are the brackets. Nothing for us to do with the brackets. So we're going to deal with the exponents. So here we have power of a power. So this 3 distributes to every single term within the brackets. We have 2 to the 3. A to the 2 times 3, which is 6. 3 to the 3, and B to the 3. Here we have A to the 6 and B to the 3. Now, we remember our fraction rules. When we are dividing a fraction, all we do is we flip the second one. So the first one doesn't change, so we'll just recopy it. This becomes a multiplication, and we get B to the 3, A to the 6. Well, here we have A to the 6 and A to the 6, so they go away. B to the 3 and B to the 3, so they go away. What are we left with? 2 to the 3 and 3 to the 3. And we're done. Okay. Any questions? All right. Square roots. Not just square roots, but roots in general. So roots are anything that you see that looks like this. Phew, excuse me. So when we see a root, so you might be used to just seeing the root of 16. But you can also see the cube root of 27, or the fourth root of 16. So what these actually represent are fraction exponents. So it's important to understand that this is an exponent. This root means exponent. Okay? So for instance, if I have a to the power of 5 over 3, this can be rewritten as denominator. So this would be the third or the cube root of a to the 5. So anytime you see a root, this is actually just a fraction exponent. Okay? And even this, a to the 1 over 4, is the same thing as the fourth root of a. So actually, when we have the normal root, that's just to the power of 1/2, because a normal root actually means 2, but we don't write it. It's like saying the power of 1. This little 1's annoying and it's unnecessary, so we don't deal with it. Here, same thing. We don't need to have the 2, so we just don't do it. All of our rules are the same, so none of these change. It's just a little bit more annoying now that we're going to have to deal with it. Whoops, with fractions. For instance, whoops, I am way too far. For instance, here we have all these different terms. We have a division, we have a power of a power, we have a whole bunch of nice stuff, and a bigger one here too. The rules do not change. They're just more annoying because we have to deal with fractions. But lucky for us, most calculators now have a fraction button. So you don't actually have to do the whole, okay, if I'm adding, I have to do the common denominator by hand on the side, and it's really annoying. The fraction button does it for you. You want to do 1/2 plus 5/10, do it. You need to know how to use this button. It makes your life a whole lot simpler. So you need to know how to use it. Most calculators, scientific calculators, have it. It's a button that looks like this. If you're not sure if your calculator has it or how to use it, take a picture of your calculator, send it to me, and I'll just give you instructions about how to use it. That makes your life a lot easier if you know how to. For instance, let's do this example. So you've got a division. Division means we subtract the exponents. So we've got our base, 3 over 2 minus 2 over 3. And we know with fractions, it's annoying. We don't really want to be doing this by hand. So we hope the trusty calculator has a fraction button, and it will do it for us. We just type in 3 over 2 minus 2 over 3, and it gives it to us as 5 over 6. We never, ever want decimals as exponents. That's just nasty. It's bad form, and we don't do this. So I don't want to see 0.83333 like this. Not okay. So always have the fraction, please, and thank you. Okay, same thing here. Power of a power means a to the 2 over 3 times 9 over 8. And again, if we do that on our calculator, it'll even reduce it for you. So you have all of the steps that are so much easier if you know how to use this button. So it reduces to 3 over 4, and we are done. This problem. So far, so good. Please, please feel free to jump in with questions at any time. Just unmute yourself for a minute or type it into the chat. I really, really want to make sure you're understanding. So anything that needs to be clarified, please jump in. Okay, we'll do number 4. So here, number 4, same thing, just a little bit more complicated. Okay, actually we'll do number 3. Number 3 is a nice little example here. So we've got a lot going on. We've got this brackets, nothing to deal with in here. We've got this exponent, distributed. So we have x to the 3 times 2 over 3. We have y to the -1 times 2 over 3. This bracket, we do the same thing. So this is the 1. If we don't see anything, it just has a 1. Not a -1, but a 1. So this gives us 1 times 1/2. I think we're okay just writing the half. And 2 times 1/2 just gives me 1. We're going to simplify this. This is really ugly. So this gives me x to the 2, y to the -2 over 3, x to the 1/2, y to the 1. Now we're multiplying. All of these are little multiplications. So from here, I'm going to put the x and the x together and the y's with the y's. So I get x to the 2 plus 1/2 and y to the -2 over 3 plus 1. This gives me 3 over 2. And your fraction button on your calculator will even do this for you. So please, please, please find it. And here we get 1 over 3. And we're done. Any questions? Perfect. All right, so these tools are going to be super important for us to be using for what we're going to start talking about now, which are radicals. I'll give you a minute to write down the blue, and then we'll get started. Okay, there's a bit more blue down here. So I'll let you write all the blue and then we'll go over the whole thing from the beginning. Okay, I'm gonna go up to the top. If you haven't finished writing, there will be a bit more opportunity to do so, so do not fret. Okay, so what we are going to be talking about today, next hour, are radicals. So a radical is a number or variable that is written in root form. So in this case, for the purposes of the radicals, we are just going to be working with these ones. So meaning that we're not working with cube roots. Anything like that, we're only going to be working with square roots. So the square root of 25, for instance, the square root of a, the square root of 15. These are all examples of radicals. For terminology's sake, the radicand is the number or variable underneath the root. So in this case, we would have 25. We wouldn't say the square root of 25 because in this case, it's not proper terminology. Our radicand is 25. In this case, our radicand is a and our radicand is 15. Just like with exponents, we have different properties because this is an exponent. Remember, this is 25 to the power of 1/2. So this thing, this radical, this root thing that we've got going on here, is an exponent. So we have the same rules. This is our basic identity that we are working with. So, probably haven't seen it like this, but we know this. So if I have the square root of 4, let's say my a is 4, we know that that is 2. We are working with the identity that 4 is equal to 2 squared. That is the whole idea. We've got the root, we've got the square. This is the identity that we are working with. Okay? All of this. So properties. If we have, sorry, you see me do some little lines here. I'm working with this new pad to do the notes, and it's not always listening to what I would like it to do, or I'm just not used to it, whichever. We have this property that says if we are multiplying something underneath the root, this can be separated, each of the factors can be separated into its own root. So if I have the root of 2 times 5, all under the same root, I can separate this into the root of 2 times the root of 5. Mathematically legitimate. This works the same way for divisions. So if I have the root of 3 divided by 10, I can separate this into the root of 3 and the root of 10 separately. What does not work is adding or subtracting. The idea is the same as with fractions. We want to change the appearance of something, we do not want to change its value. So the root of 2 plus 5. This is not, big no, the same as the root of 2 plus the root of 5. So if you type this with your calculator, this is the root of 7. What that is, and then compare it to the root of 2 plus the root of 5. You will not get the same answer because it's not the same thing. So this is not mathematically legitimate. You cannot do this. This is math illegal. Same thing here. If I have the root of 10 minus 9, this is not the same as the root of 10 minus the root of 9. So this is mathematically illegal. You are not allowed to do this. Any questions? Fabulous. So this last note says you cannot subtract radicals that do not have the same base, the same radicand. It's just like saying 3x plus 2y. This is my base. This is not the same thing as 5xy or whatever you want to say. Okay, this is not the same. This is actually simplified because they don't have the same base. That's all I can do. Same idea with radicals. So let's just do some quick little separation, putting things together, just so we're clear with what we can and cannot do. So here you notice we have two things that are multiplying under a bracket. That means that I can separate them into their own roots. Now, you're looking at this problem and probably thinking, why am I doing this? This seems silly, but it'll help us a bit with what we're going to do next. Same thing here, because I have two roots that are multiplying, just make it one root and multiply it. So actually, I'll show you the middle step here. So this gives me the root of 12 times 5, because I can multiply within the root. 12 times 5 is 60. So these are things that are mathematically legitimate. Look at these two here. I have a division. So basically what I can do is I can put this under one root. Well, I know that 6 divided by 3 is just 2. So I have the root of 2. Now you'll see that this is a lot simpler than this. And of course, we want the simplest presentation possible. This, similarly, can be separated into two roots as the root of the top and the root of the bottom. That's it, that's all. All right. If we take a look at number 5, remember that you cannot separate these, okay? You actually have to do the subtraction, and then you can deal with it. So here you get 144, which is 12 once we screwed it. But you cannot do this. You cannot say this is the root of 225 minus the root of 81. If you do that, you get 6. 6 is not 12, so these are not the same. So we do not do this ever. Alrighty. Are there any questions? Speak now. Cool. Okay. I will give you a minute to copy down the blue, and then we'll go over it. Okay. Here we go. So, radicals. We looked at what they are and just simple rules. But just like fractions, we looked at what a fraction was, what it looked like, what is a fraction, what is not a fraction. Now we are going to be doing things with them. So the first thing that we did with fractions was we learned how to reduce fractions, because we know that you don't want to be writing 100 over 200. You want to be writing 1 over 2. Same thing with radicals. We want the simplest form possible. So in this case, we want the simplest radicand possible. What we are going to be doing is we are going to be dealing with numbers first and variables second. So for numerical, for numbers, we are going to break the radicand into factors. So there are 2 different ways to do this. I'll do both ways with you. And then you can choose which way you would prefer. Okay? You are going to break the radicand into factors. If you are doing it as a factor tree, that's one thing. If you are doing it as just factors, that's something different. Once you've broken it into whatever you want to break it into, and we'll see there's a strategy behind it. You're not just doing whatever you want to do. A pair of number you see can be taken out of the root, or any square number. Square number being 4, 16, 9, 25. Anything that can be nicely square rooted. 36, 100. I could do this all day. What a waste of time that would be. Then you're going to simplify the coefficients. So like I said, there are 2 ways to do this. We're going to do the first one the first way, and the second one the second way. Now, you do have the two tools, but one of them is easier to use depending on your case scenario. So the bigger the number, the less likely you are to do it the first method. So the first method is a factor tree. So I'm asking you to rack your brain, go back to Sec 1, grade 6, to build a factor tree. So for factor trees, you're looking for prime numbers, 2s and 3s and 5s and 7s. So start with a 2, and that gives me 60. Nothing I can do here. I can pull a 2 out here. That gives me 30. Nothing I can do here. I can still pull out a 2, and that gives me 15. Nothing I can do here. This splits into 3 and 5. So all of these numbers are prime numbers. So I can rewrite 120 in that way. So we have 2 times 2 times 2 times 3 times 5. Anytime that you see a pair, you don't have to do this step, but just to make it easier or make it more clear, 2 to the 2 is 2 squared. Now I can separate this because once I have a multiplication under the root, I can take it out and separate it into several multiplications. Well, what is 2 squared square rooted? Well, that is just 2. This gives me 10. Whoops, not an equals, but a multiplication. This gives me 10. 2 times 3 times 5 gives me 30. So an easier way to rewrite this would be 10 root 30. And easier, I mean simpler. So this is the simplified version of that. Anytime you see a pair, you really don't have to do this step or this step. Really, as soon as you see a pair, it comes out in front as a single. You can jump from here to here. 2, 2, 2. So when I have a pair of 2s, it's going to come out as a single 2. So this is just to show you the thinking behind it so you understand why you can do that, but really you don't have to do those steps. They're just nonsense. Not nonsense, but makes your life a lot longer or makes the problem a lot longer. I guess it doesn't really affect the length of your life. Okay. Method number 2. You really, really, really don't want to be making a factor tree with a number that's in the thousands. That's a big pain. So what you're going to be doing is you're going to be looking for perfect square factors. Is it divisible by 4? Is it divisible by 9? Is it divisible by 16? So start off, 2592 in your calculator divided by 4. Does that work? Absolutely. So there's a 4 that goes in here. Number, is it divisible by 4? Yep. There's another 4. Is this new one divisible by 4? Not so lucky. Is it divisible by 9? Yep. That should be a 9. Is this new number divisible by 9? Yep. And what's left? A 2. So again, the step that we're about to do is not necessary, but it's just to give you an understanding of why we can do what we're doing. So each of these multiplications can be split. 4, 4, 9, 9, 2. What is the root of 4? That's 2. Same thing here. What is the root of 9? 3. What is the root of 9? 3. And I can put all of these together. So that's actually 72 root 2. So that is the simplest way to write this out. Any questions? Okay, do one more quick example before we move on. If you need me to go back up or anything, just let me know. Okay. So here we have 3 root 720. Same thing. Whatever method you're more comfortable in using, go for it. So I'm going to give you a minute, try it out, break it into factors. All right. So here I've got a 9. I've got a 16, and I've got a 5. You may have found 9, 4, 4, 5, or you may have gone all the way and said 3, 3, 2, 2, 2, 2, 5. Doesn't matter. In the end, it's the same thing. So like I said, you can skip this step. Picture this, skip the middle step. So just the square root of 9 is going to come out as a 3. The square root of 16 is going to come out as a 4. What are we left with? The root of 5. I simplify my coefficients. So 3 times 3 times 4 is 36. And I have the root of 5. So this is the simplified version of the term above. So type both of those things into your calculator, and you should get the same thing, which is 80.498. So far, so good? Fabulous. I'm interpreting your silence as meaning it's okay. So if I'm misinterpreting that, please, please, please let me know. Thank you. All right. Write down the blue, and then we'll go over it. Again, the goal is to simplify the radical as much as possible, but with with variables, it works a little differently than with numbers, okay? So basically, any even number exponent can just be taken out. Why? Because let's say we have this. If you quite remember, hopefully, because it's only been like 15 minutes, this is actually just divided by 2. So if we go back here, square root just means divided by 2, or 1/2. So anytime you have an even number exponent under the root, it just comes out and the exponent is divided by 2. So again, you don't need this middleman step. It just cuts a lot of your time. It just gives you an idea of what we're working with. So for instance, you have a to the 10. This just pops out as a. 10 divided by 2 is 5. Now you may wonder what we are going to do if it's not even. No fear. Very easy. If I have a to the 11, we know our exponent rules. This is why we went over them. I can actually write this as a to the 10 and a to the 1. Because when I'm multiplying something, I'm adding them up. These can be separated, just like that. A to the 10 comes out as a to the 5, and I'm left with an a to the 1. Or I don't write to the 1 because I don't want to. Fine. Underneath the root. You can break any any odd number into that. 13 would be a to the 12 and a to the 1. 101 would be a to the 100 and a to the 1. So any odd number exponent can just be broken into an even with a 1 left over. So that makes our lives really simple. So let's do some examples of this. So straight up, the first one, we've got an even number here. We could write this middle step if you really want to. Just put the 6 divided by 2, but it's completely acceptable. And like I said, time saving to do it. Just skip this step and go straight here. All right, here we've got an odd, which means I need to split that up right away. An even stays the way it is. So this one can be taken out as a to the 3. This one can be taken out as b to the 2. And I'm left with a inside. And I'm just going to put these together so they look nicer. That's what that's wrong. So the only thing that becomes a little bit more complicated is if we have numbers and letters together, but you just deal with them one step at a time, okay? So you're going to deal with the numbers the way you deal with numbers, then you're going to deal with the letters the way you deal with letters. So we're going to break this up. 48 is 4 times 4 times 3. This a needs to be separated into 2 and 1. The b is good to go. And the c needs to be separated into 18 and 1. Hopefully your line is straighter than mine is. Okay. This can go, this can go, this can go, this can go. That's supposed to be a 6. And this can go. So we take them out separately. This is a 2. This is a 2. This is a to the 1. This one is b to the 3. And this one is c to the 9. What are we left with under the root? We have a 3. We have an a, and we have a c. Now we just make this look better. So I have a 2 and a 2, so I have a 4 here. I have an a squared and an a, so that's a cubed. I have b cubed. I have c to the 9. And under the root, I'm left with 3a and c. So even if it's big looking, even if it's ginormous, or lots of letters, lots of exponents, lots of numbers, it's the same process. number, you deal with one way. The variables, you could even deal with them one at a time if you find it too overwhelming to deal with them all at the same time. Okay? Any questions? Okay. Quickly go onto the Google Classroom. View all. Here, there's a question. I just want to do a quick check-in with you. It says, how are we feeling about the material so far? So it's multiple question. Just gives me an idea, a little bit of feedback about how things are going, the pacing and all of that. So I'd really much appreciate it if you could just go click it. 6 of you have done it, but you did it before we even did material. So I guess your answers were completely honest. So if you want to take this time now just to go and answer that question, just gives me a bit of feedback. All right. Thank you very much for your feedback. I'll take a look at that after and we can go from there. Okay. So we have a couple of last things to look at. Copy down what's in blue and then we'll get started. Okay. So just like with expressions, and we'll take a look at this again tomorrow. But just like with expressions, when you're multiplying something or dividing, I want to look at them separately. Essentially what you're going to be doing is you're going to be dealing with the coefficients and the radicals separately. So just like when you had 2x to the 6 times 3x to the 5, you would deal with coefficients. You'd say, okay, well, this is 2 times 3, which is 6, x to the 11. So I dealt with this multiplication first and this multiplication second. What we're going to be doing. So you deal with this multiplication, so you multiply the coefficients to give you a new coefficient. And then you multiply the radicals to give you a new radical under a single root. It is the same thing for division, except you divide the coefficients here, and you divide the two roots under one big single root. All right. So let's just work on some basic ones here. So if I want to put this together, this is a division. If I want to put this together, first I'm going to deal with the coefficients. So I have 2 divided by 5. Then I'm going to deal with the roots, and I'm going to put them under one root together. Then you're going to simplify if necessary. So in this case, we see that the a and the a squared can be put together. 2 and 5, not much I can do there. We use our exponent rules. We know that 2 minus 1 gives me 1, and it should stay on the bottom. Meaning that this is what we have. This would be acceptable, but if you want to just simplify it a little bit, you can do this as well. Why can we do this? Well, we know the square root of 1 is just 1. All right, number 2. Number 2 is now multiplication. We handle it the same way. We multiply our coefficients first. So in this case, you can write this down if you want to, but again, you just want to do time-saving things. So 5 times 6, and then these two things get multiplied under one root. Then I'm just going to put some stuff together, just like that. And that is the simplified radical. I'm going to give you 2 or 3 minutes. I'd like you to try number 3 and number 4, and then we'll take a look at them together. Remember, take it step by step, coefficients, and then the radicals, the roots. Okay, let's take a quick look. So the first problem is a division. So I'll deal with the coefficients first. 12 divided by 4. And then I'm going to make one big root with the 20 and the 5 all together. Here I have 12 divided by 4, which gives me 3. 20 divided by 5 is actually 4. This can be dealt with. Square root of 4 is 2, so this gives me 6. This is not enough. It has to go all the way to the end, okay? Just like with fractions, let's say I have 20 over 100, and I want to reduce it. If I divide it by 2, I could get 10 over 50. This is not done. This is a middle step. I need to go all the way to 1 over 5. That is the same as this. You can't stop there. You have to go all the way to the end. You have to go all the way to the 1 over 5. Okay. Here, same thing. We have the 30 and we have the 6. So here, the negative 30 and the negative 6 gives me 180. 5 times 8 gives me 40. Now, 40 needs to be taken care of as well. 40 is in this section here, okay? 40 can be written as 4 times 10, which means that 4 can be removed. It's removed as a 2, which gives us a final answer of this. Any questions? Do we not have questions because we're not used to asking questions in this way, or we really don't have questions?
Is there any chance of uploading these things later on?
These ones specifically?
Yeah.
Probably for the first class, but for the second class, the notes will be uploaded early enough that you should be following along with me.
All right.
Okay?
Sure.
Right. So you can just write this down. This is the same. This is the same expression that we just dealt with, so you're just rewriting it here. Also, don't forget that all of these Hangouts are recorded So you can go back, and if you've missed anything or want to rewatch a section, you can just go on my YouTube channel, and all of these are uploaded, and you can watch from beginning to end. Or just specific sections, because I'm assuming you don't want to rewatch the entire thing, as entertaining as this is. Okay. Multiplication, division, we're just going to do more complicated problems. So these are just the steps. I'll give you a minute to write them down. We'll go over the steps. All right, so the steps for solving, we just did it. I just wanted to do it in a more formal sense. So steps for solving, multiplication, division, the same thing. You're going to multiply, divide the coefficients. You will multiply, divide the terms under the root. You're going to simplify the root if necessary. So you saw in some of our basic problems even, sometimes the root needed to be simplified, sometimes it didn't. So you have to use your judgment, because it needs to be, again, like with fractions, it needs to be as simple as possible. And then once you're done, all the coefficients get mashed together. Are we ready? Fabulous. We're going to do some examples, some more complicated than others. We'll try to do a mix of some of the more basic examples and some of the more complicated examples. So I'll do number 1 and 2 with you, and then you'll do C on your own. So here we have multiplication. So just like with exponents, we have this little 1 as a coefficient when we don't see a coefficient. So 13 times 1 is just 13. Now we have 7 times 14, which ends up under our bracket. Now I'm going to give myself some time. I know that 14 is 2 times 7. Because of that, I have 2 7s, which means they can come out of the root as 1. I put the 13 with the 7, and that gives me 91 root 2. So we check under the root. The root is simplified. There's no doubles in variables. There's no doubles in numbers. We're good to go. Here we go. Same thing. Coefficient, coefficient. 4, x, y. We've got our 3, not 13. We have got our 3, and we've got our 12x. Now, 12 can be written as 3 times 4, which means that this can come out and this can come out. So we end up with 1 3, so we've got 2 3's under, which means 1 3 out. 4 square rooted is 2, and I'm left with an x underneath my root. So if I put my numbers together, I have 4 times 3 times 2. That gives me 24xy, and I still have the square root of the x.
Updated class list.
Thank you.
You're welcome.
All right, I'd like you to try C on your own, and then we'll take a look at it together. So you have about 2 minutes to try that out. All right, let's take a look at this example. So here I put my coefficients together. And I'm going to put my roots together. So now I want to see here what I can reduce and here what I can reduce. So 6 and 2 reduce. I'm going to get, here we go. 6 divided by 2 gives me 3. And A, B are still there. The 2 and the 162 reduce. So if I have 162 divided by 2, I have 81. The a squared, this should be a cubed, just miswritten by me. A cubed and a to the 1 gives me a squared on top. We can take that. In this case, the a squared is going to come out as an a single. 81 comes out as a 9. Now, my last step is to reduce anything I can. So the a's go away, and the 3 and the 9 reduce, and that gives me 1 over 3. Are there any questions?
Where did you get the 9 from?
81 square rooted gives me 9, so it can be pulled out as a 9. Anything else? Okay, so just to wrap up, just to go over a couple of things. I'm going to post these ones with the solutions in them for today only, because I know with the confusion of the documents and all of that stuff, you may not have had time to print them. but the expectation tomorrow is that you print it. So this afternoon, I will upload both the notes and the handouts for tomorrow's class. So you'll be able to print those out and have them on hand with you. That way you can fill in the blue things directly on the document and write down any special notes or anything like that. Okay? Just uploaded now in the last minute. That's your assignment for today. So take a look at this. There are 3 different problems, like I said. So you are to complete them, everything that we've done so far. You're to complete them and upload the picture here. When you are done, you click turn in and accept, and then I'll get a notification that you've completed it. Okay? You have that to complete that I'll give you feedback on either today or tomorrow. And then you also have this handout that's been uploaded to work on. So tons of problems like we did today. The addition subtraction we didn't get to, so you can skip those for now. We'll get to that first thing tomorrow morning. And so that should be clear. So just do all the problems, multiplication, division, simplifying, all that kind of stuff. I will, again, Google Classroom, I will be uploading the solutions to that tonight, probably later, to give you some time to work on it without the answers. It's one thing if you can understand my solution, it's another if you can replicate it yourself. So please, please try to do these problems without the solution guide, but then you'll have the solution guide to check your answer. Is everyone clear on what the expectations are for tomorrow's class? All right, fantastic. If you have any problems between now and then, feel free to post in the Google Classroom. I'll be checking it regularly. Feel free to send me an email as well. If you'd prefer to send me an email, go ahead. If there's nothing else, or that's the last thing, if you want me to check out your calculator and tell you about the fraction button, please send me an email. If not, I will see you at the same time tomorrow morning, 10:30 sharp. Have a great afternoon.